So let's start by drawing a 147-degree angle in standard position. So that would put us in the second quadrant. And if we're going to draw the angle, again, we always start from the positive horizontal axis. So this is my angle theta, 147 degrees. Now I want to find the cosine of 147 and the cosine of the reference angle. To mark the reference angle, remember the acute positive angle attached to the horizontal axis. Let's find the measure. It's in the second quadrant, so the measure of our theta reference would be 180 minus 147, or 33 degrees. Now, let's find the cosine of 147 and the cosine of 33. Pull out our calculators. We want to check and make sure in our mode that we are in degree mode, not radians. We are. Now I'll simply ask for the cosine of 147. And I will get negative 0.83867, etc. Now let's take the cosine of our reference angle. That was 33 degrees. And here I get positive 0.83867. So rounded to 3 decimal places. So why is one negative and one positive? If we think about our horizontal distance from the origin for this angle, we'll see that it gives me a negative u value. And if we remember that r is always positive, for our actual angle, we are talking about a negative u over a positive r. For our reference angle of 33 degrees, if we were to draw a 33-degree angle, our u value would be positive. Hence, a positive value for the reference angle. Let's take a look at it from another perspective. The terminal side of angle theta in standard position contains the point 8, negative 5. So let's find that point. There we are. And that would put us right here. If we were going to sketch the angle in standard position from the positive horizontal axis to the terminal side. So there is theta. The sine of theta would be the vertical distance, which is negative 5, over r. To calculate r, we're going to have to use the Pythagorean theorem. We know that this is 8, and this is negative 5, so r is going to be the square root of 8 squared plus negative 5 squared, which would be the square root of 89. The sine would be the vertical distance over r, so it turns out to be negative 5 over root 89. And the cosine would be the horizontal distance over r, or 8 over root 89. Our last example, we're going to create a new graph, y equals 4 sine theta. And we want to know what transformation of the parent sine function is this. Well, by the parent function, we mean the basic sine theta graph. So what we did to y equals sine theta was we multiplied it by 4. We multiplied the entire equation by 4, so that means that we are performing a vertical dilation, since we took the whole function and multiplied it by 4. So we would say a vertical dilation by a factor of 4. To sketch the graph, we'd identify key points where it would be easy to show this vertical dilation. So those points we call the critical points. Critical points where the function is equal to 0 or at a maximum or a minimum. Here at the origin, it's equal to 0 when we multiply by 4. We stay there at 0. We reach a maximum at 90 degrees of 1. But now we're going to multiply that by 4, so at 90 degrees, I'm going to move up and mark a point at 4. 1 times 4. At 180, we're at 0 again. At 270, I'm at negative 1, so now I drop down to negative 4. And at 360, I'm back to 0. 4 times 0 is 0. Now we play a game of connect the dots. And this would be our sketch. And there's our lesson.